Soccer pundit Andy Goldstein has a viral science problem.
I'm on a chair in space and I've got the best binoculars, most powerful binoculars in the world, and I zoom in, and from wherever I am in space on my chair, I can see Bentley standing on the North Pole. If I then point my binoculars down whilst I'm in space, will I see that person upside down? And if I do, and then I decide to get into a spaceship from my chair and fly to see him, how do I land?
Okay, first let's blast Goldstein off into space, a concept which many TalkSport listeners will be sympathetic towards. In order to be able to see people at both poles from one position, Goldstein will need to be far away from the Earth. If Goldstein now rotates himself to be in the same orientation as Bentley at the North Pole, then Goldstein will see Bentley standing in the same orientation as himself. If Goldstein then diverts his eyes down to, say, Alan Brazil at the South Pole, he will see Alan as being flipped 180 degrees relative to himself. However, the confusion comes when Goldstein starts talking about the concept of upside down. Up and down are defined by the direction of the gravitational pull exerted on an object. On the Earth, we know that down means towards the ground, because the Earth's gravitational pull pulls us towards the ground and the centre of the Earth. However, when Goldstein is in space far away from the Earth, how does he define up and down when there's no strong local gravity? The simplest way to define down would be towards the centre of the strongest close-by gravitational source, the Earth. If we do that, neither Bentley nor Brazil is upside down relative to this common standard. Both of them is the right way up, with their heads towards space and their feet towards the ground. Goldstein is the odd one out because he's laying on his side. Goldstein now suggests that he'll get in his rocket ship in his current orientation and fly towards Alan Brazil. But this would be like flying the space shuttle in a flipped orientation towards the Earth's atmosphere. First up, you probably wouldn't have to worry about landing because you haven't orientated your heat shield towards the atmosphere. However, if you did make it towards the ground, you would start to notice that the top of your spaceship is orientated towards the centre of the Earth, and that you are indeed upside down as defined by the increasing local gravity. You would quickly realise that you need to flip over and place your wheels in the direction of the local gravitational pull to be able to land. The local gravity provides a compelling definition of what up and down now mean. A definition that was pretty inconsequential, or simply didn't exist, when you were far away from the Earth and its gravitational pull. Of course, once you've flipped over and landed, you can enjoy the pearls of Alan Brazil's wisdom.
Hey, what's going on here?
For more, be scientific and bad, and find me over on YouTube.